Hi, dear students, Dr. here. So today I'm going to discuss about this question. So you have to find ddx of y of this question, and k is a constant here. So x and y are variables. So we have to use the technique called implicit differentiation here. So what you do technically, you are going to introduce the ddx operator in both sides. So I'm going to do the in detail calculation in here so that you will understand the full depth of the solution here. So I'm going to introduce ddx operator in the left hand side, and then when I do that you get this. So k is a constant, I told you, so it's going to be ddx of k here. Now ddx of k, since k is a constant, is going to be 0. So this is 0 over here. So now you can separately operate on these two terms here. So I'm going to operate ddx on this term and later on that term. So when I do that, I get ddx of x squared y squared plus 2 is a constant, I'm going to take that out, and then I'm going to operate ddx of ddx operator on x squared y, and the right hand side is 0. So pretty easy. So now what we can do, here you can see there is a multiplication and there is a multiplication here. So carefully you have to use the product rule here. So if you do that, x squared, so x squared ddx of y squared plus then y squared ddx of x squared. So I have used the product rule here, right? Now for the second term, I'm going to take 2 out, and then if I use the product rule here, so it's going to be x squared ddx is acting on y plus y. Now ddx operator is acting on the x squared. So that's all about it. Now what you can do is, we can see that this you can't differentiate. How come you differentiate y squared in terms of x? Impossible. This one you can. The answer to this one is 2x. That's base case number 1, right? So all method specialist method students should know that. So this is what you need to isolate. So there is no problem with this term. And this one is 2x. So that's fine. So my problem is here. So how to deal with this guy? So to do this, we use the concept which everybody knows, chain rule. So I'm going to do the construction here. So I can't differentiate y squared respect to x. What I'm going to do, I'm going to introduce y here, and I'm going to differentiate that respect to y. And this construction I'm going to destruct over here. So this logical phenomena is called the chain rule. Now you can see how the chain rule works here. Now if you carefully look into this one is possible, and that would be 2y, base case number 1, and this is what we need to isolate, right? So you have the same thing here and here. So what I'm going to do now, I'm going to rewrite this one with all of these simplified terms. So if I do that, the first term is x squared. First term is x squared. First term is x squared. Okay, so now I'm going to take this term over here, and then this got simplified into this, so I'm going to copy that, x squared times 2y, x squared times 2y, and then I'm going to write ddx of y, right? And then plus, here I get 2xy squared, so I get 2xy squared, plus, now this guy, so it's going to be 2x squared dy over dx, 2x squared dy over dx, right? Then from here you get plus, you get 2y, and then you get 2x, and that's going to be 0, right? So that's pretty easy. Now what you're going to do, I'm going to isolate these two, factorize, move the rest of the things to the other side. So when I do that, I get dy over dx from here, so I get 2yx squared. So when I get this one here, it's going to be 2x squared. So when I move all the pluses into the other side, it's going to be minus. So when I move this one to the other side, it's going to be minus 4xy. When I move this one to the other side, it's going to be minus 2xy squared. Easy. Now, I can subject ddx of y. While I am doing that, I'm going to simplify these a little bit. I'm going to take 2x minus 2x out. So when I do that, I get 2y here. I get plus y. I can take y as well. Okay, but that's fine. So I will leave that here. Then from here, I'm going to get 2x squared out. So it's going to be 2x squared. So when I do that, so I get y plus 1. Right? So if you want to have a nice answer finally, so I'm going to take y out as well. So I'm going to produce 1 here and I'm going to put y here. So that's all about it. So that's how you do the implicit diff properly.